I would like to invite Hilda Cristina Mariaca Orozco, who is going to join me in a second on the virtual stage. Let me introduce and welcome Cristina. She is the International Strategic and Technical Coordinator at the Global Energy District Program, UNIDO. There you are. How are you doing, Cristina? Nice to see you.
Okay, nice to see you, Julika. Thank you. Good morning. Can you hear me?
Yes, perfectly fine.
Okay,
so it's a pleasure to welcome you. And when you're ready, just start with your presentation.
Okay, I can see the presentation and the control right now.
Okay, I think we just have to wait 1 second. It needs to upload again. Can you see it right now?
Yes.
Perfect.
Where I am. Okay.
Okay, there you go. Yes.
Could you see the presentation right now?
Everything works perfectly fine.
Okay, perfect. Thank you. Good morning, everybody. Thank you very much for the Green Cooling Summit for this invitation. I am very happy to share with you the Energy District Strategy in Colombia. My name is Cristina Mariaca, and I'm leading this strategy here in Colombia since 2013, and now it becomes a global strategy. Okay, the strategy of district energy in Colombia starts in 2013 as a solution for building air conditioning in the urban areas. So we started thinking in district cooling as a solution for the commitments of the Montreal Protocol, the climate change commitments too. So this was a strategy that burns in the Ministry of Environment of Colombia, and that was worked with the support of the Switzerland government cooperation, SECO. The first phase of this strategy starts assessing with the willingness of the different stakeholders about the implementation of district cooling. So in this first phase between 2013 to 2019, district energy becomes a possible strategy in Colombia. And we start pushing for a first district cooling pilot in Medellin, here in a city called Medellin, here in Colombia. So this first pilot project was very important for us because we can touch what is a district cooling, how we can build it, how we can design it, and how we can operate it. This district cooling, it's very important, and I want to take some of the ideas of the speakers before me. And the district cooling of Alpujarra in Medellin, it's operating with ammonia regarding the interest of introducing natural refrigerants in the country. In this first phase, we introduced the concept to different stakeholders in 4 other cities in the country, and that was a very, very welcome idea or infrastructure for become an important driver to energy efficiency for the cities and climate change mitigation action for the cities too. So in this first phase, we saw in general what is district cooling in general. So we started to work in a second phase that starts in 2019 to 2024, really, with the support of Switzerland government too, and in this time with the support of UNIDO, and the Nation Unit's Industrial Development Organization. So in this second phase, we start to support or to strong the activities of district energy in the country. So, okay. In this second stage, we implement the project in 10 cities regarding the national policies and the municipality and the subnational policies too. So we start the implementation in this second phase with 3 pillars. That was to strong the institutional framework. So it was important. Why? Because to establish a new market for air conditioning for buildings needs strong policies that support it, but to incentive the new market and incentive the new infrastructure. So we worked in a national level for introduce district cooling as part of energy efficiency policies, energy transition policy, climate change. District energy is an NDC here in Colombia, and we worked a little with the sustainable construction here in Colombia too. At regional level, in the 10 series, we introduced the concept of district cooling for the climate change city programs, and some of them, for example, for the sustainable construction code. And in 2 cities, we achieved to be part of the planning, the urban planning of the city. So that was a very, very important framework for introducing, for implementing district energy in the political framework. The second pillar was knowledge sustainability. So we need professionals, technicians, prepared to abord the new challenge to introduce this infrastructure, but not only in the technical way. We need architects, lawyers, economists, financial, working with us regarding the contracts, for example, because our more important achievement is to change the mind of the end users, to change to from having a system, only one system, to having a service. Having a cooling as a service is how we can say that. So in this knowledge sustainability, we started to work with the academic, with the companies in engineering, trying to move the knowledge to support this change of business, the business case of the air conditioning for buildings in Colombia. So in this knowledge sustainability, we support the Air Conditioning Association to introduce the Center of Knowledge and Center of Research, CIDARE, and we propose a contest for universities regarding subjects for district energy, not only in technical aspects, but in political incentives, architectural incentives, planning, urban planning incentives, etc. And we can have the first Latin American District Energy Conference in the 2023. And the third market development, we look for incentive the business case in the different cities with specific feasibility studies. So we arrive to have feasibility studies in different sectors in order to demonstrate the use of the district cooling and district heating in the different contexts of the different cities. So right now, Colombia has 6 operating district cooling right now, among 1 district energy in industry. And there are at least 2 projects in starting operation right now. So this is important because the strategy achieved the mobilization of investments, private investment in the country, and right now we are pioneers in the region, operating district cooling in different sectors. For example, we have the first one, the pilot was La Alpujarra, was in Medellin for institutional buildings. Serena del Mar is a district cooling in Cartagena that works with an hospital and an university, and it's the first one to working with the residential sector. The project of Potenza in the east of the country, it's for commercial building, and one of the most interesting district energy, it's air liquid, that is a district energy, industrial district energy that provides more than 4 energy services, not only cooling, heating, electricity, and gases, nitrogen and CO2 for the industry. So our most important achievements in Colombia, in the political framework, we achieved to have the first technical regulation for thermal installation in Colombia. This is important because thermal energy was worked here as generation, electrical generation power only. But this regulation can give us the opportunity to speak, to talk about the thermal energy as a use. The use in our buildings, the use in our houses, industries, etc. So that was very important. Other very important tool is the develop of energy maps to planning the possible district energy in or district cooling in the cities. That was a public tool to provide information for the city planners in the cities. We worked with the public procurement. We conduct a pilot in the public procurement regarding the needs, the legal and commercial needs to introduce district cooling as part of the market in the public buildings. And as I said before, we introduced district cooling in city policies. In the market level, we worked in 10 cities. We achieved to have 21 feasibility studies in health sector, commercial sector, industrial, okay, that's in general. And we achieved to have more than 40 public entities involved in this project, so that we can say that we make a big change. The not having anyone involved in district cooling, to have more than 40 entities right now, and more than 8 companies able to design, to build, to operate district cooling and district energy in Colombia. Colombian companies. These Colombian companies are right now exporting their service in district cooling, and that is very, very important for us. And in the knowledge, sustainability component, we achieved to have the qualification catalog. As I said before, energy in Colombia in general, when people talk about energy, everyone thinks about electricity. So it was a very important change for us in our country to have qualification catalog, in order to introduce thermal energy as part of our lives. So we achieved to have this qualification catalog worked with the Ministry of Education and the Ministry of Labor, and introducing to the standard levels for technicians in order to have standards for operating district energy and cooling here in Colombia. CIDARE is the Center of Research and Knowledge. We held 3 university contests. Our first LATAM conference, that was the most important achievements in Colombia. So this is a very, very successfully experience here, and the Switzerland Corporation was very, very, very happy with our achievement here in Colombia. So we can present for them a proposal in order to scaling up the experience of Colombia for other developing countries. So right now, we are working in order to introduce the Global Energy District Program supported by SECO and UNIDO. And our objective is to introduce this infrastructure and this experience in other countries in order to give an alternative for climate change, for Montreal Protocol commitments, for the energy transition, etc., in other 8 countries, priority countries for SECO. So right now we are working with other countries in order to introduce this infrastructure that we expect can give a solution for the climate change and the ozone depleting substance phase out. Thank you very much.
Thank you very, very much, Cristina Mariaca Orozco, and congratulations to your successful work. I see many questions in the chat already. We are going to come to the questions after all of the presentations of this session. So thank you very much, Cristina, and we are going to move on to our next presentation. And for that, I would like to invite Joseph Amanka Baffoe to the virtual stage. And he is head of climate change and ozone department. And I'm very interested in learning about nearly zero energy buildings with propane chillers in Ghana. Hello, Joseph.
Good afternoon, everyone. As I've been introduced already, I'm Joseph Baffoe with the Environmental Protection Authority and with the Climate Change and Ozone Department. Today, I'll be talking to you about the nearly zero energy building with R290 chiller in Ghana. And I just want to say that by introduction, this is a policy for Ghana in terms of looking at buildings that are energy efficient using low GWP refrigerants. Basically, there are a number of things that Ghana is doing to make sure that we are able to make that transition. There are a number of policies that are underway. For example, we have the Ghana Building Code, which actually talks about green building requirements for any person who intends to put up a structure. Of course, it's not very much detailed, but it still gives some requirements to ensure that buildings are green. And of course, key to this is the type of air conditioners that will be installed or cooling appliances that will be installed in the building. Currently, we are developing the green building guideline support that we're having from CKCN that is looking at some guide or standards that should guide people in terms of what they require in putting up green buildings. And this is going to sort of help architects and engineers to have some ideas in mind in terms of how they are going to go about structuring or putting up green buildings, and of course to eventually also reduce emissions. So basically, this building that you are seeing in this picture here is one of the first buildings that we pride ourselves in terms of green, because it has all what it takes to make it green. Of course, it's nearly zero. It's not zero. So, of course, we still have room for improvement. But this is to say that this facility has come up. It's in the premises of the Energy Commission of Ghana. And this is a collaboration between Ghana and Germany that saw the structure being put up. And one key idea was to also make sure that at least it has a chiller that eventually works on R290 that makes it even more green. The building was officially commissioned in Accra in October 2024. And the objective for putting up this building is to minimize energy consumption and produce majority of the building's energy needs through solar PV. So you can already see here that with the use of the chiller and with the use of solar PV, we are already attaining a high level of energy efficiency so far as the structure is concerned. So that puts some less draw in terms of power from the national grid. It also installs a climate and environmentally friendly, in fact, the chiller that is PFAS free in terms of operations. So that also makes it an additional benefit in terms of environmentally friendliness. So this is basically from a Ghana-Germany Sustainable Partnership project, and it has been financed solely by the German Ministry of Economic Cooperation and Development. Technical support by GIZ. So in terms of all the technical aspects of the building, GIZ handled that, even ensuring that the chiller is imported and installed, and local partnerships are also fully part of ensuring the installation. The implementation, of course, the other partners that are also very much into this, apart from GIZ, there's the Energy Commission where the facility actually sits. The Ministry of Energy, of course, a very key partner when it comes to energy provision. And the National Ozone Unit where I sit, because eventually refrigerants that are used have to also align with our arrangements under the Montreal Protocol and the Kigali Amendment. So this actually shows a strong partnership between Ghana and Germany in advancing sustainable progress. So what is the building going to be used for? Of course, it looks quite massive, but basically we intend to have this building used for conference facilities. There are a lot of programs that organize so far as the Energy Commission is concerned in relation to other stakeholders. And this structure with all the greenness is going to showcase how we're able to have meetings without directly very much having impact on the environment. So the conference facilities also have some offices that will also be used, so that eventually those who also occupy it will benefit from this greenness. The idea for this project, like I said, Ghana has other ideas in terms of going green when it comes to buildings. So there are a number of green initiatives that have gone on in the country, and you realize that they have not fully gotten up to where we intend to have this facility, to have in terms of using natural refrigerants and making sure that they are energy efficient and less environment impact on the environment. So this building is going to ensure that as much as we're able to look at low GHG emissions, we are also able to use that as a demonstration for other projects to also emulate. At the end of the day, we want a situation where you are looking at what has to be learned, what is good in terms of this facility, and what can we replicate when we are putting up other facilities. So basically, this building is going to ensure that other public buildings are looked at in a green way when it comes to scale up. The innovative office space also demonstrate how buildings can both be energy efficient and sustainable, setting a new standard for green design in Ghana. I've already told you that we're already looking at a guideline that is setting up some standards when green buildings are concerned. In fact, this one is the first one that we have in terms of green, because in terms of consumptions, it is very energy efficient, and that now becomes the new standard when we are looking at other buildings in the country. So eventually, this becomes a new baseline to have other buildings also look at. So I'm glad to say that for the chiller, this is the first we have in Africa, R290 chiller, and that is not surprising that we had a lot of challenge trying to bring it here to install and even get other people to be part of it, because of course, once it's installed, you need to maintain it, then you need to have people who understand and be able to do that, and that we are in big trouble. So this was installed also in 2024, and it has a 115 kilowatt chiller. This is a 115 kilowatt chiller and uses natural refrigerant R290. And the PV is also supported to ensure that the whole building is energy efficient. The chiller provides great thermodynamic properties in terms of energy efficiency. If you look at the temperatures of Ghana, it's quite hot, averagely around 32 degrees. So the chiller is able to accommodate these temperatures and keep the cooling ideally as possible for the work environment. In terms of sustainable air conditioning regarding the chiller, the R290 basically, as we all know, has a GWP of 3, which is almost 0, and has negative, do not have any negative environmental impact. So this makes it very good. And in fact, Ghana as a country is adopting the use of R290 refrigerant in terms of transitioning from the HFCs and the HCFCs by 2030 to about 70% in terms of transitioning. So this comes as a good source in terms of our overall picture in this transitioning. Of course, it's also PFAS free and do not break down to TFAs. I think David talked a lot about TFAs, and this makes it quite good. And if you saw the table that he showed, you saw that for TFAs, when it comes to hydrocarbons, it's basically 0. The entire building and its chiller are mainly 88% powered by 50 kilowatt PV, which minimizes direct emissions, setting a pioneering example for sustainable construction. The emission reductions are also about 50% when it comes to the environment. So that puts less strain for where power is generated to feed the structure. So of course, you are not using more energy from the grid. And the chiller combined with the energy efficiency and natural refrigerant can reduce total emissions by 40% in industrial countries. And in the global south, there is about 60%. For installation and support, the design and installation of the chiller has been supported by GIZ and HEAT, a consultant firm. And ST Frigo manufactured the R290 and was shipped to Accra for installation. So basically, we needed to have some support and experts to be able to have this thing done. And we also had to recruit a local expert to also be able to be part of the installation. And this idea is because, like I mentioned earlier, in terms of sustenance and maintenance, we need to have those local expertise understand what is here, and they can easily attend to it. Not that we are eventually always going back to make sure that we have an international expert to come back to look at the chiller if there are issues that we need to address. So basically, for regulatory compliance, this innovation is geared towards achieving the RAC sector targets are set out in Ghana's nationally determined contribution. In fact, this target that I talked about in terms of transitioning to 70% of hydrocarbons is set out in nationally determined contributions. And that is also in agreement with what we have to do regarding the Paris Agreement. If you look at the Kigali Amendment under our CAPES with strong indications of ensuring that Ghana transitions more to natural refrigerants. And most of the time, if you look at energy consumption, this is coming from air conditioners in buildings. So that is a big part, for example, if we're able to have that transition. If you look at commercial facilities, there's also a lot of cooling there because it's generally warm. So there's a lot of use when it comes to air conditioners. Cost is a big factor when you are using it. So eventually, you want to make sure that energy savings are a greater part of it so that some monies are saved so far as consumers are concerned. So basically, this is the end of my presentation, but I want to say that at least with the support of GIZ, we have already initiated some transitioning in terms of R290 air conditioners. So far, we don't have a lot in the system, but we have at least about 400 working R290 air conditioners where we have had some studies or analysis to show how good in terms of how good they are in terms of energy efficiency. So we are doing the little that we can. We are making sure that at least buildings become a greater part when it comes to refrigerants and energy efficiency of cooling appliances. And for me, I think this is the way to go to help the environment. Thank you very much.
Thank you very, very much. And thank you for your efforts, Joseph Amakwa Baffoe, and thank you for your presentation. I see many questions in the chat. We will come to these questions after our last presentation for that session. But before we do so, just please show some emotions, some clapping hands, or some words of respect in the chat for our speakers. Thank you very much. And with that, I would like to invite Andreas Koch, who is team leader for district and cities at the German Energy Agency, dena, Berlin. And he is going to present on sustainable heating. So now we are switching from the mainly cooling part to the heating part in buildings. Welcome.
Thank you.
There you are.
Yes, thank you, Judika. Thanks for inviting me, and thanks for the great presentation. Very, very interesting to see. And now I think I have the challenge to move from the cooling climate to heating climate, and also moving back in scale or moving up in scale, because I wanted to share some slides on the strategies that are now starting to take place in Germany more and more on the question of how we trying to arrive at a more sustainable way of heating houses and getting this part of the energy transition, which we refer to as a heat transition, done. So I hope I can. I'm seeing now the first slide. Is it? I'm seeing a welcome slide. So if I move forward, or with some music, Jurika, I'm not sure if I'm seeing the right slide, but
no, you're not. Somebody's decided that it's time for a little movement right now.
Yes.
So right
That's
now,
excellent.
Can you? Yes, exactly. We are switching to your presentation, and right now you should see your first slide.
Yes, thanks a lot. Yes, always good to start with a bit of music. So and maybe we can have that afterwards. But first, I have to put in some diagrams and slides, not without music, but I'm gonna deliver the text to that. So first of all, let me just show you, and that also highlights the technical question that also were addressed by Joseph, like on refrigerants, on technologies for individual buildings and for multifamily buildings. So what we see here is a scenario built by Prognos Institute in Germany for the evolution of heating systems in the residential sector, which makes quite a big part of the heating needs in Germany at national level. So what is depicted here is basically what we're trying to achieve as a transition from a fossil world on the left side of both of these diagrams. So most of our heating systems have been and are still based on fossil fuels, fuel and natural gas specifically. And while there's a lot of technology options that are available and that are on the market, here in this scenario, you could see that there's a lot of interest or expectations on the heat pump market. So for individual buildings, this specific scenario shows a great move towards individual heating systems based on heat pumps on the various sources. And in multifamily buildings, you could see that these orange bars depicting heat pump systems are still very dominant in the future, or still are a part of the solution scenario here. But then on the blue bars, a lot of district heating systems, systems at the city scale or at a neighborhood scale, distributing mainly hot water, heated water to the buildings in rather dense urban areas, are part of the solutions that are seen here to move to a more sustainable way of heating homes in the residential sector. So while this is part of the technology choices, what I really wanted to point at with the presentation is a way. I think there's a bit of a shift in the way that we are looking at the different choices of technologies, and this is also has to do with mixing it up with urban planning, with urban development. So one particular scarce resource, as we see it now, is also space, and we have in many ways now moved to a system of, in cities, having an obligation to develop strategic planning for the heating transition, and that is based on a new law that came in place last year, the law on heat planning and the decarbonization of district energy systems, or of heating networks. And there was a recast of the Building Energy Act that was much disputed, but that is also linked to this new law on heat planning. And in consequence, what we're seeing with the communities making new plans for urban areas is that in addition to decentral solutions that we see, of course, also in many places, and that are then compliant with the laws on building energy, as it has been for the past decades. Now more and more the question of district heating systems, either existing or new district heating systems, are more prominent in the discussion. So there's a close link between the two laws, and more a link also of the question of the choice of technologies in terms of the space. So where you are in a community, in what kind of structure you are, if you want. So space becomes a resource that has to be accounted for in the balance, if you want. So one way of looking at it is, and that has been part of, for example, planning and district heating networks for a long time, is looking also at different settlement patterns. So here is quite a schematic done by the DVD for different low and high dense residential patterns. So this is part of saying it will also determine not only the question of the choice of individual heating versus district heating systems, as we saw on the first slide, but it's also a question of the available space for using environmental energy. So and that is to say, it will be a question when we move to heat pumps based on air, ground, or water systems, of the question of the availability of the source to run those heat pumps, in addition, of course, to electricity. which is most of the heat pump systems in the German market would be seen as electric heat pumps, using environmental or waste energy to supply heat to the households. And here we depicted it more as a question of the availability in contrast to the efficiency. So while air is an abundant resource for using to increase the temperature with the use of heat pumps, is typically seen as mostly available in, for example, residential areas with single-family houses. So with efficient buildings, it's of course possible to use air, water, heat pump systems to supply the energy needs, but then you would need a certain amount of space in terms of noise protection. So proximity to your neighbors would be an issue, and of course the question of efficiency using outdoor air in the German climate is in winter times, of course, less efficient than using more stable heat sources. So while we move then to maybe solar as an also very much available systems in ratio to the ground floor air, especially also in less denser areas. The ground-based systems like borehole heat exchangers or ground collectors would be seen as a more efficient heat source for running heat pumps. But then, of course, it's a question of the availability. And you could imagine that in the German context, we would see that in the less dense areas, we would have possibly outdoor space available for using to drill borehole heat exchangers in a very dense city center. With respect to the amount of heat needed, this can become an issue, especially a question of using public space. That is not always a simple question in the supply of heat. And then, as we move to the more efficient system using water as a or waste heat as a source of heat for the heat pump systems, the availability becomes, of course, more question of specific spaces, adjacent industry, tertiary buildings, or wastewater are sources that are more and more discussed, like IT centers or the sewage system as a source for waste heat is now more and more explored in the cities, as it's a quite efficient as a kind of high temperature source for heat pumps. But as it depicted here, availability is very much subject to the specific location you're at in the city. And this is, as an example, part of the strategic planning that is done here from the city of Leipzig, where you could see what these kind of solution spaces could look like. When I said it's a question of space, it also becomes a bit of a question of the urban area and the built-up structures. Like many European cities, or probably also many cities worldwide, we would see in lots of German cities a higher density at the city center and less dense areas in the outskirts of the city. And here you can see the equivalent of the heating supply solutions. Like the red areas in the middle of the cities are supplied by district heating networks, with the green areas foreseen as expansion of these systems. And on the outer spaces, you would see, probably, I'm not from Leipzig myself, but probably less dense areas, specifically row houses or individual buildings that are then depicted here as decentral supplied solutions. As I said, there's many technology options available, of course, but in many of the scenarios, the heat pumps will play a very dominant role. And then, which is most interesting also, is that in between those areas, so when you come to the not to the outskirts, but just to the fringe of the city centers, that will be very interesting parts to look at. Here it's marked as undetermined. So these are areas that are not yet decided. Would they be dense enough to be supplied by district heating systems? Would there be operators to actually install such systems? Or would they be seen rather as decentral supplied systems, which is a bit of a mix? Of course, that can happen, but it will be a question that is not a clear-cut answer, and of course that needs some planning, and hence the strategic plans, I think, are quite quite a relevant mechanism that is now introduced. And here you could see what that looks like in practice as one of the example I picked from a project we're running for the Ministry of Economy and Energy. It's called Gebäudeforum klimaneutral, so climate neutral building forum. It is there for also supplying information for these kind of works, for in-depth information of building renovation and supply systems. And here it's one of the examples that is depicted in more detail also on those websites. It's a settlement in the city of Cologne that has been built in the 50s and was renovated 2015 to 2019. And I think the interesting part is here that it's a mix of those technologies, and it's also important, I think, to say it's not a black and white decision. Sometimes it can also be a mix of solutions. So of course, at one point there was a renovation strategy to reduce energy needs, which is, I mean, the smart way or the preferred way we would like to see most of those renovations projects going on. And then it's a hybrid supply system, which is part of why the law is laid out to allow different heating system in combination. So here there's a connection to the district heating system, but this is used only to provide peak load. And for the base load system, there's air water heat pumps installed that are supported also by on-site electricity production by PV modules on the roofs, with battery storage system to increase the self-consumption rate. So it's a mix of local production of electricity, use of air as the heat source, as the outside. And as I said in the earlier slides, it's it's less efficient than to run heat pumps on air in Germany in wintertime, because air temperatures can get quite low. In wintertime, there's the peak load supply by the district heating system. So that's a combination to overcome this dilemma and include heat pumps and district heating. And as in the discussions up front of the presentations, was asked to share some question on prices. So just maybe a snapshot of another project we're running to compare the different options for different settlement types, and we want to publish this in June. But as a preview, what we could see here is a comparison of the annual cost of heat pumps, heating networks, and low-X heating networks, so low temperature networks with heat pumps installed in each household. But let's stick to the first two bars. And as a message, maybe
Andreas, I'm sorry, you have 1.5 minutes left. Okay.
Yes, that's perfect. So we are quite close in terms of costs, and you could here see that still the operating cost takes up less than the investment cost, and that's a bit of the transition that we're also looking at. But then let's move to the last slide, because that's, I think, is even more important than costs in a way, because what we do, and this is again an image taken from City of Leipzig, which I like a lot, because it's looking at different scales and importances of one, transforming the citywide district heating, so decarbonizing the district heating system that still is running a lot on fossil fuels. It is, of course, also about decarbonization of heat in buildings, that is renovation schemes, but also individual building supply systems. And this is the municipal heat plan, which I said is a new instrument since beginning of last year. But then, of course, linked to that, and especially quite obvious when you look at heat pump systems, it's a transformation of energy supply systems. It's the transformation of our networks, and here I'd say district heating networks, but also the gas and the electricity networks. But then the most important messages, and sorry to make that as a last point on this slides, but is that, of course, it's also about places to work and live, and then it's about provision of healthy and more sustainable spaces. So this is taken together in this graphic as a reminder, it's not only about the systems and the linkage of systems to the networks, but mostly about the spaces that we're creating. Thanks a lot.
Thank you a lot. So thank you, Dr. Andreas Koch. People applauding for you. And with that, I would like every speaker of this session to join me on the virtual stage. So Cristina Mariaca Orozco and Joseph Amankwa Baffoe, please join us together with Andreas, and we can start our Q&A session. And since Cristina and Joseph, unfortunately, due to time reasons, are not going to be there for our session 6, I would start with questions directed to you, Joseph and Hilda. So we have a question from the chat to you, Cristina, which says, at what temperature level do you operate the district cooling grid?
Right now, our district cooling is only for air conditioning in buildings. So the regime is 7 degrees, 12 degrees right now in the primary water circuit.
Thank you so much. And a question to Joseph. Joseph, are you still here with us?
Yes, I'm still here.
Perfect. So the question directed to you is, are the sun shadow elements of the building in Ghana also movable, driven by the electricity of the PV panels?
Yes, definitely it does. For example, if you have a small amount of shadow on the PV panel, that reduces the electricity that is generated. So you want to, as much as possible, avoid that to make sure that you have maximum sunshine to have the energy that you want to derive from the solar panel. Thank you.
Okay, thank you very much. Let us now open the floor for the direct questions. Oh, Kivon disappeared in that very moment. Maybe your question was already answered and the last hand disappeared and it's back again. So it's Landus. No, it's back. Who wants to use the opportunity and ask a question directly? There you are. So we have Landosi. You are now able to unmute yourself and ask your question. The floor is yours. If you want to, you can ask your question. If you want to unmute yourself, you have to wait a little bit because we need to give you the permission to unmute yourself. And what you still have to do then is the actual unmuting, okay? So if you want your voice to be heard, just click the mic and unmute yourself. And maybe we are moving on to Dr. Andrea Nacoins. Second in line.
Yeah, okay. Yeah, thank you very much. Thanks for your presentations. I unfortunately missed the first ones. But what I'm a doctor and I'm working in the field of heat in Germany and and on heat resilience, and like what keeps coming up at the moment is that the communal heat planning that we just saw, what I found quite interesting, is also very crucial for district cooling planning. And since people are saying it everywhere and you didn't mention it, I wanted to know if this does actually play a part, or I mean, it seems to be quite limited to me. or if we really look at it, and this is the heat planning and this is the cooling planning.
Yes, thank you. So it is as you said, like the predominant obligation for the communities is a heat plan. So as I would say, in many, especially on the smaller communities, they would focus on the heating aspect. But what at least what I've seen in the maybe more in those communities have been doing this for a bit of more time, that to some respect also the question of looking for waste heat potentials, therefore cooling becomes a certain question as seen as cooling requirements as a source for fueling heating. Having said that, I'd say that this is more a question of the front runners right now who makes this connection already. But to my knowledge, it's not part of the obligatory part of the planning for all communities, especially I think in smaller communities, this would rather be a side topic. But I would agree to you that it's a very important topic because, of course, the question of heat stress becomes much more and more prominent in the discussion. So I think it's more a question of time when those are linked together.
Yeah, and as far as I know, you need more energy for cooling, so it would be like kind of a waste of time to now plan it with like less energy consumption.
You know what we are going to do right now, because this gives me the perfect opportunity to introduce our networking break.